Good morning, geometry students, or if you're in ninth hour, good afternoon. Today we're going to continue our work on circles. And so our work today with circles, can't see that, let's try that again. Our work with circles today is on writing equations. Let's recap some of the things that you worked on last week, please. The formal standard form of an equation for a circle is x minus h squared plus y minus k squared equals r squared. Please recall that HK is the middle of the circle, what we call the center, and R represents the radius. To review how to graph a circle from last week, what you worked on with Mr. Ironside, I would like you to please graph the equation x plus 2 squared plus y minus 6 squared equals 25. Remember that your steps in graphing involve, first, identify the center of the circle, HK, and second, identify the radius. Plot the center of your circle and count out your radius in the four directions, up, down, left, and right. I'll give you a moment to give that a try, please. When we're identifying the center of a circle, we look for the value with x and the value with y. However, since our formula had a subtraction sign, if it's positive, it's really the opposite. So if there's a subtraction, now an addition, it's -2. Here, the subtraction is part of the formula, making the k value just 6. Whenever there's subtraction in the formula, you're thinking of it like the opposite. So -2, up, 1, 2, 3, 4, 5, 6. That is our center. From our center, we need to identify the radius and go up, down, left, and right with it. Well, we have r squared matching up with 25, so square root will give us the radius. And so then our radius is 5. So I go over 5 in both directions. So let's see, 2, 3, 4, 5, 6, 7. And then up and down, and I believe that's what I had counted out. And then we do our very best to try and make it look circular. And that's challenging to do. All right, so we plotted our circle. You also looked at, if we don't have it in standard form, how do I write it in that form? And the value in doing so is easily being able to identify the center and the radius in order to graph. All right, please keep in mind as we work through our work today, the standard form of an equation for a circle. The next thing we're going to look at is what happens if you are given the center and a radius. how would we get the equation? So let's take a look at an example and talk through it. If the center of a circle, let's say, is located at -2, 7, and the radius of my circle is 3, what would the equation of that circle be? Like I asked just moments ago, we need that you remember x minus h squared plus y minus k squared equals r squared. Center, though, is hk, and radius goes in for r. So then we have x minus -2 squared plus y minus k is 7, so 7 all squared, equals our radius of 3 squared. We can clean this up just slightly. Minus a negative is really plus a positive, so this is x plus 2 squared, and y minus 7 squared. 3 squared, 9. We just wrote the equation for our circle given the center and the radius. All we need to do is substitute h, k, and r. No matter what we're given today, our goal is to substitute h, k, and r. But we won't always be given them as explicitly as we were here. Let's see what in different situations where that can occur. If we are provided or given the center and a point on the circle, so let's come up with an example here. Let's say our center is located at (2, 5), and we have a point on the circle of, let's say, 5, 7. Hopefully this point to you, the center, screams HK. That's a huge help. We already have 2 of the 3 things we're trying to look for. Our H value is 2, our K value is 5, however, we don't know the radius from our point 5,7. What is a radius? A radius is the distance from the center to a point on the circle. Well, if I know the distance from the center to the point on the circle, then I can fill in all the pieces I need. And so we need to find distance between the two. Distance formula. And this is why we reviewed this at the beginning of our unit. To find the distance between 2 coordinate points, we take our x values, 5 and 2, and subtract. Squared. Our y values, their difference, squared. Then I have 5 minus 2 is 3. 3 squared makes 9. 7 take off 5 is 2. 2 squared is 4. I get square root of 13. Now this can be deceiving. This d here represents distance, but this is also really the radius. And I'm not going to find out what that is as a decimal, and I'll show you why. Remember our standard form of a circle, x minus h squared plus y minus k squared equals r squared. Our h value is 2. Our k value is 5. Our radius is square root of 13. But what happens to a square root and a square? Exactly, they cancel out. And so we have x minus 2 squared plus y minus 5 squared equals 13. We have one last situation of information we can be provided. This information is if you are given the end points of a diameter. Let's think about that intuitive understanding of what a diameter is. So on my circle here, if I draw in the diameter, and I know these 2 points on the end, how do you think we're going to get the center? The center is the middle point. To find a middle point, we do our midpoint formula. To find a radius, well, there's a few ways we could come up with that. We could find the distance or the length of the whole diameter and cut in half. Or we could find the distance from this new point, the midpoint, to one of the endpoints, and that would be our radius. So radius, either way, how you want to approach it, we're going to have to use the distance formula. And let's wrap up our lesson today with one last example. So the diameter endpoints are 18, negative 13, and 4, negative 3. You could plot it out, but those numbers are relatively large, and I don't want to make a mistake plotting and trying to find the middle exactly using a graph. So we're going to use our algebraic formula for midpoint. To get the center, we average the points. We'll take 18 and 4 and cut in half, and negative 13 and negative 3 add together, cut in half. That provides us with 22 cut in half, 11. Negative 13 and negative 3 together make negative 16, cut in half, negative 8. So this here is my h and k value. Now our last job is to find the radius. Well, if this is my center, then I need to pick a point to work with. And I'm going to choose this one, just because the numbers are smaller. It doesn't matter which endpoint you choose. So think of it as I'm choosing the center to this endpoint, but you could really work with the center to that endpoint, or you could find this whole distance and divide by 2. You have options. So I'm choosing the center and one of the endpoints to come up with my radius. The radius uses our distance formula. We'll subtract our x coordinates, 11 minus 4, and squared. Negative 8 minus negative 3 squared. 11 minus 4, 7. 7 squared, 49. Negative 8 minus negative 3, minus a negative, chop chop, add a positive, and we get negative 5. Negative 5 times negative 5 is positive 25. We carefully add together to get 74. Don't want to think this is 64, making it nicely 8. So it's square root of 74. Not going to worry about breaking down that square root because remember in our last one, we just had to square it anyways. So now we're ready. X minus our h value squared plus y, take off the k value squared, equals our radius squared. Let's fill in the blanks. H is 11, y minus k, k is our negative 8, and our radius, square root of 74. Cleaning it up just slightly, x minus 11 squared plus y plus 8 squared equals 74.